right, hello and welcome. Thanks for being with us at Coalesce. On the last full day of sessions, the big question on everyone's mind, I think, is will my voice hold out? Lots of good conversations this week. Thanks for being here. Thanks for joining us online. My name is Ryan McGibney. I'm from the DBT Labs partnerships team, and it's my pleasure to be here introducing a couple folks from one of our services partners, Slalom Build. In fact, Slalom was named the DBT Labs Services Consulting Partner of the Year earlier this week. Congratulations. I'm introducing the speakers for this talk, which is entitled Seeing is Believing, Data Observability with DBT. And our speakers are Eli Jackson. Eli is from Seattle, Washington, and he has a dog named Lincoln. We also have Clay Cuppinger. Clay is from Charlotte, North Carolina, and he likes to play 9-ball and poker. Just as a reminder, all the chat and Q&A is taking place on DBT Slack. The channel is Coalesce Workshop Seeing is Believing. You still have time to join the DBT Slack community. If you have not yet, just go to community.getdbt.com. And I will kick it over to Clay and Eli.
Awesome. Thank you so much. Hi, my name is Eli Jackson. I'm from Seattle, Washington, like he shared. A fun fact about me is I'm actually ambidextrous, so I can write with my left hand and throw with my right hand. This may be the only piece of information you walk away with, but at least it's kind of fun. And I'll pass it over to Clay to do his intro.
Test. Hey everyone, I'm Clay Cuppinger. I'm an architect at Slalom Build. Fun fact about me, I couldn't come up with a fun fact in time for our slides, so that's me.
Great, thanks, Clay. Slalom has been one of the best companies I've ever worked for. It's a purpose-led global business and technology consulting company. We build digital products, data solutions, and cloud platforms. Our 14,000 consultants and builders are working over 40 cities throughout North America, Europe, Australia, and Japan. We work with a wide range of industries, global brands, and startups that are just disrupting the status quo. Here are a few of the brands that we've worked with recently. Unfortunately, I have not been able to work with any of these. And with those customers, we get to build the best cloud. We get to build with the best cloud and data partners, including DBT. And we are so grateful that this year, Slalom Build was awarded the Consulting Partner of the Year for 2022. I know we're looking forward to continuing this growth with DBT and continue to be such great partners. At a high level, I'm just going to go through what we're going to be talking about today. We'll be covering that typical problem that I know all of you have been trying to solve for. Is my stuff actually working? We hope through this workshop you'll be able to take away a simple approach to see if in fact your stuff is actually working. We will talk about the technologies and infrastructure we have seen successfully combined with DBT to solve that larger question, is my stuff actually working? For the most part, all you will need is a data store, a log aggregator, and DBT. We'll go through a demo of one way you could do this, and then if time permits, we'll go on to Q&A. Like David was saying earlier, if you could join the Slack channel, we'll be looking at that actively and try to answer those questions as we go. And then at the end, we'll go through any outstanding questions one at a time. Okay. Let's first talk why you want to have observability with your modern platform with DBT. One, you want to monitor the data pipeline health by combining logs and additional rich sources of information. You want to minimize data downtime and associated engineering time spent resolving breakages, bottlenecks, and optimizations. And lastly, you want to deliver on those SLAs. Data engineering has SLAs, and you want to confidently deliver on those. What Slalom has done to kind of reach these goals is we've revamped existing architecture with more scalable, flexible compute clusters managed by container orchestration services. We've leveraged structured logging, metadata, lineage in dbt, and injected operational metrics for data observability. We've displayed insightful visualizations to streamline the engineering cycle. As a result, our clients haven't fired us yet, and they have been pretty happy. What we've seen is real-time visibility on the state of ETLs on the individual process level. We've reduced engineering time on data pipelines, plumbing, and improved employee satisfaction. We've lowered data downtime, resulting in more confident SLAs and decision-making. So we really have these 4 pillars of data observability: metrics, metadata, lineage, and logs. The metrics help you understand the accuracy and the reliability and the shape of the data. Metadata helps you understand the structure, completeness, and freshness of the data. And lineage helps you understand where insights come from and the relationships between any issues. Logs, which we're all used to and love seeing, help you understand usage and spot issues. From those 4 pillars, we tried to look at these 6 attributes of data and get these questions answered for these 6 points. Freshness, the question being, how do you know how recently your things have been working? Flexibility, how do you know your stuff will work when a new feature is added or an old one is deprecated? Reliability, what happens if one of your dependent services has an outage? Completeness, do you know if anything is missing? Speed, how soon can you expect your queries to run? Accuracy, how closely does your data reflect what actually happened? Next, I'm going to pass it off to my colleague Clay to talk about data observability simplified with dbt.
Yeah, thank you, Eli. Sweet. Okay. That work? There we go. Okay, so in dbt 1.0, structured logs were added as a feature. So basically what that means is that the serialization of logs can be formed in JSON, which can then be parsed by a log aggregator, database engine. So if you want to go see what types of events are logged in the structured logs, I would go to the events/types.py. That has every single, every single different type of log event and the struct, the shape of the data. Let's see. There we go. Okay, so at a high level, we have an EKS cluster running dbt on a container, fluentd forwarding that to a S3 bucket. Snowflake parses that JSON, and then Snowsite does the visualization. As far as the types of information that's stored in the logs out of the box, the main one that we're focusing on today is execution time. You can also inject through configuration a specific metric that you're interested in, say row count. It's the one that's coming to the top of my head right now, as well as CPU and IOPS from your data warehouse. Cool. So we're going to talk a little bit about z-scores and bell curves for a second. So what we really want to metric on is a z-score, which is the variance from a standard deviation, which is how variant that bell curve is right there. There's a rule of thumb. If you have more than 2 standard deviations away from the mean on either side, that captures 95% of the population, or outside of that, that's 5%. And so when you take a look at z-scores that are greater than 2, there shouldn't be more than 5% of them. So now I will go to the demo. Here. right, so we have a few graphs here. The very first one, total runtime. This is the duration of all models in seconds for arbitrary models. They don't really matter what they are. There's a shift here, right, on the right side here that occurs, and how big of a deal that is kind of hard to say. Setting an SLO, saying your model shouldn't exceed some runtime, is arbitrary. So rather than doing that, let's set some statistical heuristics and go from there. So here, make that bigger. So here's the cohorts broken up by model IDs, which are unique identifiers to the specific DBT models, right? This also applies to snapshots, seeds, tests, any resource type in DBT you can log this way. And we can still see kind of like a little bit of a variance, but it's not that big of a variance if you're just looking at it from a bird's eye view. So this chart here is basically, if I can zoom in on this, the z-scores. So on or about February 7th, we just started seeing aberrant behavior. It appears to only apply to 2 models, but it's kind of hard to tell just from this whether or not that's even really a problem. So on this chart here, we have like a distribution, right? Where 1 is an anomaly and 0 is standard behavior. Anomaly being greater than 2 standard deviations away from the mean. So we would expect that this would be 5% of the population. Just looking at this value here, 93 of 907 is roughly 10%. And so we know that the normal distribution of variance is broken, and therefore we can fire off an alert. And then lastly, we can drill into specific anomalies for specific models. So this is the aforementioned 10%er. And here's the breakdown of variance and when it occurred. So on February 7th, we had 12 runs that occurred that have 2 standard deviations away from the mean of variance, and that's not good. Yeah. So that's pretty much my whole spiel. I think we go to QA next.
Yeah. Let me just catch up on the Slack channel real quick. Someone looks like they asked if the slides going to be available. Yes, we will be posting them as a PDF. If you have a question, if you could put it in Slack. There's a delay with the stream, so it would get a little awkward otherwise. Yeah, and Dave attached actually the query for Snowflake specifically to do some kind of view similar to the z-scores that we showed today. So that uses a S3 staging, external staging table, and then we just do a view on top of that to get those metrics. Something that I was curious about is if you could do this in DBT Cloud or DBT Core. You could do it for either. We posted the DBT Core HTTP endpoint for that, and then for DBT Core, it's just a CLI argument. We got another question. Is it possible to include model tags in these monitoring stats?
Tags, like, that would be part of the config, right?
I would think so.
I know any metadata for the configuration is stored. I'm not sure off the top of my head if tags are stored. They are? Yeah, so correct, yeah. You could also do checksums, for example, when your code changes. that could be a way of correlating when those variant events occur. Yeah.
Yeah, that's a good idea. Another question, do you have these calculations integrated with your on-call tooling, e.g. pager duty?
So we have it we have it with our log aggregating and reporting service. I don't know what tooling we can say, so.
Yeah, it depends on the client, but yeah, that would be the next step, right? Is how do you take these metrics and create some kind of action plan from them, like trigger some kind of on-call event. Another question, do you always query raw logs, or you are thinking about loading them into a DB? Like into a database. So like in this case, we're just using S3 to stage the data. We could actually, materialize it into the database. It kind of depends.
Yeah, I would say there's a lot of, it's JSON, so it's not a tabular document, and it can change. So formatting that into a table is kind of tricky to do. I would probably leave it to something like Elasticsearch.
Yeah. Can you say more about the use cases for dashboard? What do you do when you spot an anomaly?
Well, I think it's like trying to deduce whether or not there is a problem with the anomaly. So the use case would be, I've made a code change and I have a data volume change. How do I make the distinction between the two as to whether or not that's a problem from the code side or the data side? And you can do that by, again, going off of checksums. It depends. I would say that against your entire model set, you should not be experiencing that kind of variance. A single model, maybe. But if you have hundreds and hundreds of models and you see a correlation with your runtimes going up, this is an easy way of drilling into that.
Yeah, there could be different distributions that fit your model's runtimes depending on what you have set up. But this is kind of like a nice catch-all for like a normally distributed run set. Can you somehow pre-mark things when you know there will be large changes, i.e. entering a new market and you'll be growing the data 20%? So like getting ahead of...
Yeah, I would think that would come off of depending on your, I'm blanking on what the term is in Splunk, but do not disturb period. You can do that if you're fully reloading the data warehouse. Conversely, if this is a brand new model and you don't have a large population, you filter out the sets that don't have a population standard of more than 100 executions. So if it's the first time the model ever ran, it shouldn't be, you don't even have a standard deviation to check against. So.
Looks like we have one more typing. I think I've hit all the ones that have been posted. Yeah, so today has actually been a lot of fun. We really appreciated the opportunity to come out here. We're happy to keep answering questions. If you want to keep posting them on Slack, we'll continue to look at them. Slalom is hiring. We would love to work with you guys, so feel free to reach out to us and shoot us your resume, take a look at the openings. But yeah, thanks so much for your time and your attention, and have a good rest of your day.
All right, thanks Clay and Eli for the presentation. Thanks everybody for being here. I'll give a quick plug for a session coming up in about a half hour at 3:15 Central Time from Grace Goheen from DBT Labs Analytics Engineering Team about the DBT Project Evaluator Package, which is a way to ensure that your DBT project is following best practices. So, thanks.